Hello everybody, welcome to Higher Math Help, and today we will be doing derivatives in our first video in our Calculus 1 series. Okay, so today we will be talking about the constant rule and the power rule. Okay, so the constant rule states that if the function is only a constant, so this is our function, if it's only a constant, then the derivative of this function, so this is the derivative notation, the derivative of the function will be 0. So as you can see, the y came here and the c value came here. Anyways, this is just the notation we'll be seeing, d of y over d of x. And then our power rule states that if a function is equals to, so if our function is y equals x to the n, our derivative will be n times x to the n minus 1. This looks a bit intimidating, but once you do a few examples, everything will make more sense. So let's do our first example. So our first example is y equals 2. Our derivative of this function will be 0, as stated in the power rule. And this is our final answer. Our next example, it's y equals x to the power 2. So our power rule states that the derivative of x to the n is equal to n times n minus 2. In this example, n is equal to 2. So it will be 2 times x to the n minus 1. N minus 1 is 1. So our final answer will be 2x, or 2 times x. In our next example, our function is y equals 1 over 3 times x to the power 4. So our derivative will be, so in this example, we can see that we have a constant at the front and x to the power 4 at the back. Now, although we have a constant, the constant rule will not apply here because we have an x term. So in this case, you would multiply 1 over 3 by the derivative of x to the power 4. So this is what it will look like. So it'll be 1 over 3 times, now we find the derivative of x to the power 4. We know our n value is equal to 4. So it will be 4 times x to the power of n minus 1. So 4 minus 1 will be 3. And to simplify our answer, it will be 4 over 3 times x to the power of 3. And this is our final answer. Okay, now we can talk a bit about notation. So right now, to represent our function, we have seen that it is y equals blah, blah, blah. And you have also seen that a function could be represented as f of x equals blah, blah, blah. But for our derivative, we have seen our notation, which is d of y equals d of x equals blah, blah, blah. However, in some textbooks, or the way your teacher or professor might teach it, it would be y prime equals blah, 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 or f of x prime equals blah, blah, blah. Now, all of these notations mean the same thing. It's just that some textbook might have a preference of what to pick, but if you see any of these notations, just know that they mean the derivative of the function. Okay, so for our next example, our function is y equals 1 over 2 times x to the negative 2. So our derivative, y prime, also means d of y over d of x. Our derivative will be 1 over 2 times the derivative of x to the power of n of negative 2, sorry. So n is equal to negative 2. So we multiply everything by negative 2 times x to the power of n minus 1. So n minus 1 will be negative 3. So our final answer would be negative x to the power of negative 3. This is our final answer. Okay, so in this example, our function is 1 over 5 times x to the power of 7 over 6 minus root x. So this function is a bit more difficult, but we can split it up into two parts. So the first term and the second term. Now you may be thinking you don't know how to differentiate root x, but remember that root x is the equivalent of x to the power of 1 over 2. And now this makes our function much easier to differentiate. So our function is in two parts, so you would have to apply the power rule twice. So once to the first term and again to the second term. So our differentiate function would be, so remember this part has a constant, so you multiply everything by the constant, which is 1 over 5, times 7 over 6, which is our n value, times x, to the power of n minus 1. So 7 over 6 minus 1 is equal to 1 over 6. So x to the power of 1 over 6. And then we will carry the minus sign, and then find the differentiate for this function. So it would be 1 over 2 times x, and n minus 1 will be negative 1 over 2. And then we can simplify this function. So it would be 7 over 30 times x to the power of 1 over 6 minus 1 over 2 times root x. And this is our final answer. In our next example, our function is y equals 1 over 7 times x to the power of negative 5 over 4 over 5, sorry, plus 7. Okay, so this function is also two terms, the first term and the second term. However, we can see that our second term is just a constant. So our derivative would be, so we differentiate the two terms. The first term, the power rule would apply, and the second term, the constant rule would apply. So our first term will be 1 over 7 times negative 4 over 5. This is our n value, negative 4 over 5 times x to the power of n minus 1. So it would be negative 4 minus 1, which is negative 9 over 5. So x to the power of negative 9 over 5. Oops. And then our second part of the function is just a constant. So it would be 0, so plus 0. And if we simplify this function, it will be negative 4 over 35 times x to the negative 9 over 5. And this will be our final answer. Okay, so in our last example, our function is x plus 2 to the power of 2. Now this function also looks intimidating because it's x plus 2 to the power of 2. Now, later in our series, we will cover a video that talks about the chain rule, which will make this differentiating these type of functions much easier. However, right now, we only have the constant rule and the power rule, so we have to make use of that. Luckily, this function, we can expand this function. So x plus 2 to the power of 2 can be written as x to the power of 2 plus 4x plus 4. And this is much easier to differentiate. So f prime of x, this is also equivalent to y prime or d of y over d of x. This is another notation for differentiated function, as if you remember. So now we could differentiate these three terms. So the power rule applies to the first term, which is 2x. And now the second term, so it's 4x. So it's a constant times our n value. Our n value is actually 1 because the 1 is not shown here. And then it's x to the, times x to the power of 1 minus 1. 1 minus 1 is 0. And then our last term is a constant, so it's also a 0. So if we want to simplify this function, it would be 2x plus, and if you remember, x to the power of 0 is also 1, so it would be 2x plus 4. And this will be our final answer. Thanks for watching the video, and I hope this video helped. Make sure to leave a like and subscribe.